welcome all of you to join Fred's workshop. So Fred Starner is actually a director of the contextual computing and also the longest serving and for the contextual computing group. And then he is now teaching in Georgia Tech, and he is a founder of the Animal Computer Interaction Lab and works with the Georgia Tech You Become group and also the Brain Lab. So he has created the computational interfaces and agents for use in everyday life, mobile environments, and combine the wearable and also ubiquitous computing technologies with the techniques from the field of the artificial intelligence, pattern recognition, and also computer interaction. So we're very honored to have Fred to come to give us a workshop today. So welcome. So you may start your.
Thank you.
Yeah.
Well, if you let me see if I can share my screen here.
Yeah.
Currently, I have it that says host disabled attendee screen sharing.
Yes.
So if you can.
So you can try to share your screen now.
There we go. Thank you.
Yeah.
Okay. Well, thank you everyone for having me. Today we are going to have two sessions. Here the first we're going to have more a traditional talk where I'm talking about symbiotic AI. The second part, I was talking with Rita, and we decided that you might like to see some of the hardware that I use, basically the wearable computing stuff. And so that my desks and labs are now covered with hardware. I think we have about 20 or so different displays, most of which are working, that we are going to cover in the second meeting, second part. That'll be much more informal, and we can have some fun. And gone through several different phases of that. The first one was at MIT Media Lab when I was a graduate student, and that's the one on the left. That's a picture from 1994, I believe. That is a private eye with a twiddler and a 12 megahertz 286 with 16 megabytes of RAM and I think 40 megabytes of hard drive. In the center is a more recent system that was from around 2000. The display up in the upper right is actually pretty old. What I have here, it's from 1997. During that time, we made some living laboratories. What is a living laboratory? Well, the idea is to make technology that you can live with in a day-to-day existence, hopefully with a community of other folks. And that way you sort of live the future and figure out what the challenges as well as the opportunities are. And so we've done that several times at the MIT Media Lab from 93 to 95. We had a handful of us, I'd say about 10 to 12 folks who actually had wearable computers, a few of whom actually wore it every day as part of the daily life. We see some of them at the top. Then at Georgia Tech, the folks on the right-hand side, that was started in 1999. Again, these are people who could wear these systems on a daily in their daily life and see what having a wearable computer would be like before we had any of the devices that we have now. And this is, a lot of prototype hardware, and you have to go through a lot of difficulty to wear it. And we'll see some of that equipment in the second hour. When I got to Google, I was fortunate that I ran across some colleagues of mine. Back in 1998, I had gone to a conference called New Paradigms in Computing, hosted by Ted Seltzer, and that was the conference that was invitation only, and I believe Marvin Minsky brought me as one of his students, and Terry Winograd, I believe, brought Larry Page and Sergey Brin, who you all probably know as the founders of Google. And one thing about, looking like one of these people who has these displays in front of their eyes, as soon as that gets a lot of attention, and so people tend to come up to you and ask you what it is you're doing. And so I was fortunate that some of the first people who found me at the conference were Larry and Sergey. Came up to me and said, "What is that thing?" And so I gave them a demonstration of wearable computers back in 1998. We talked for a little while about our research. Mine was about trying to make these machines that could augment your daily life. And Larry and Sergey were working on this new search engine called Google. And we talked about how great it would be to actually have the ability to access to the world's knowledge through your eyeball, through a display that you always had with you. Come around 2010, I sent Sergey an email saying that you hadn't seen this research in a while. Why don't you come past Georgia Tech and we'll show you some of the advances in wearable computers. And his response was, well, why don't you come out here and do a demonstration to Google? I said, okay. And the next thing I realized is that they had the previous month worked with this guy in the front of the picture down here. His name is Babak Parviz, to start a whole wearable computing project. And so one of the things we did at Google to basically see whether or not this work, what we were doing with Google Glass, was useful, is to wear it ourselves. And so this is an image of the team. And if you have a Google Glass XE, you can actually see this image. It's an Easter egg in the hardware. What you see is everybody's wearing one, and that was true. So we had a couple hundred people on the team. We all had a wearable device that we almost everybody wore it every day, including Larry and Sergey. Yeah.
Sorry for my interruption. There is a comment for like, can anyone see the PPT? So do you have the PPT at this moment, or you just introduce the stuff to them?
I'm sorry, you can't see my screen?
Yeah. Because they say that they can't see the PPT in the chat box.
That is disappointing. Okay.
Yeah.
Let me see what's going on. Let me try sharing it a little bit differently. Well, it looks like we had a problem with the share. So what I'm going to do is I'm going to go up to a PDF that will work instead. Okay. My apologies, folks. First time I've had that happen. Okay, let me check what I'm seeing here, and I'm also not seeing that on Zoom here. Okay, so we'll try one other thing. There we go, that worked. Well, okay, that's what you should have been seeing. My apologies. Okay. Well, that's not going to be quite the right format, and I'll have to change things around a little bit, but please tell me if you don't see the right thing. I'm going to go back to the chat so I can see it. Great. So now I can see the commentary as well as my screen. Give me one more second here. What I'm going to do is be able to see the chat at the same time I am talking. My apologies for the inconvenience. There we go. And I'm sorry, folks, but my machine has just frozen on the other screen. So what I'm going to do is reboot it.
So there's
You
echo.
have the slides you can put up. Rita, do you have the slides that you can put up?
Yes, I can actually try to share the one that you sent me earlier. Hold on a second.
Okay, we'll race so you can get there the first, the quickest.
Yeah. So probably I just share mine. So you just let me know which page that you were in.
Yep. I just think it's like, page 4 or so.
Page 4. So just go to page 4.
And can you steal the screen for me?
Sorry?
Can you steal the screen? Right now, I seem to be stuck on sharing.
Stuck on sharing? I can share that on my side, but then if there's a share from your side, then I have to stop my sharing now, so that you can just share it by your side.
Well, I'll be back up here in just a second.
Okay.
I guess this is the danger danger of leaving the machine on all night.
So Fred, your side is okay?
It's still coming up, I'm afraid. Okay, I seem to have it again. Now I believe you can see me. Is that correct?
We can actually see your screen and so as your side.
Okay.
Yeah.
Great. I'm now looking at this from multiple angles, so that I can keep a track of it. Great. So I think we're good. And I see the chat. Great. My apologies, folks. So we're using our backup here. This is the image I was talking about before. If you have a Google Glass XE, you can find this image. And the point I was trying to make here is that we were trying to do living laboratories where you live with the technology for months or years before you actually try to give it to anybody else. And we started doing that, at the universities for many years, for decades, literally, before we tried to make a commercial product. And once we got to the stage of actually having a wearable computer that we thought that was useful in daily life, we announced it at Google. That was in 2012. That caused a lot of press. And everybody got all excited about the display, and that was the reason we did that, was so that we could actually have wear the display in public and actually see how it would work. And from the hundreds of people that we had internally, then we had many thousands of people externally to Google actually using it in their daily life. If you went to the Google I/O, I think in 2013 or 2014, you'd see thousands of people wandering around with Google Glass on as part of their daily life. Now, how does this work? Well, the wearable computers that most people think about these days are these head-worn displays, but there's many different types of wearable computers. We've had Bluetooth headsets for many decades, and they've been very popular. The MP3 music players, probably the first wearable computers out there that were extremely popular. We have fitness sensors. We all have all sorts of wearable computers now. A smartphone, in many senses, is a wearable computer. But what folks get excited about is these head-worn displays. And what's interesting about those head-worn displays is that you can have a relatively crude system, like the ones back here, and these ones covered our left eye back then. But you can get an overlay effect where the screen seems to float in front of you and it seems to be transparent, even though it is opaque. Now, how does that work? Well, let me do a little experiment with you. If you all can look at my image for a second on the screen, and what I'd like you to do is to take your thumb and close your, let's see if I get this right, close your right eye and line your thumb up on top of my face, right? So you can't see my head on the computer screen in front of you. Okay, everybody have that? Right. So you can't see my face because your thumb is blocking your face, or my face. And now I want you to open up your right eye, and suddenly it's like you can see through your thumb. And that is the same illusion that happens with a head-worn display. the eyes, the human visual system, shares the image between both eyes. So it seems like to you that you can see through your thumb. It seems like your thumb is transparent, even though it's not. And all we're doing with these opaque headboard displays is putting some optics in front of it so that the display seems in focus when you look at it. But you get this illusion that you can see through these opaque displays. One of the first things we did with this is augmented memory. Now here's something called the remembrance agent. This is a system from 1993, and what it does is it tries to look to see what you're typing and pull up suggestions, what might be relevant from your past emails or from your past notes that you've been taking, and create one-line summaries at the bottom. For example, here we're talking about notification software is proactive. We're actually writing a paper on the remembrance agent when we took this screenshot. And what's happening is as we type each sentence or each paragraph, the bottom of the screen updates with potential suggestions of what we might be interested in while we're writing that. So in some sense, you can think of this, I think you can see this sort of thing these days on Reddit. When you try to write a Reddit post, one of the first things it does as you write the post is it pulls up previous posts that might be relevant to your current typing. Now think of that having that sort of ability, but not just with your Reddit post, but with every email you write, every paper you write, every note you write, something that's continuously monitoring your environment and trying to suggest to you things stuff in your past that might be relevant to what you're currently working on. Now, we can go further with this and make it so that you can, well, actually, I believe I have a video here that I can show on this. Now this is, okay, so now I have to, I'm afraid, switch, because we're doing this the hard way. What we're going to do is switch out the application I'm sharing. Here we go. And now I see we're working again. Great. So this is some video that was shot from, I think, 1997, where Alan Alda, who's a famous American actor, is interviewing me for a TV show called Scientific American Frontiers. And as he's interviewing me, I'm wearing a headboard display. And we'll ignore the topic that Alan is talking about right now, which is privacy. But I just want you to look at the bottom of my screen as he talks. And as I type, you can see it's suggesting things that might be relevant to the conversation. Here we go.
This cafe is just around the corner from MIT in Cambridge. As you can see, computers are everywhere here. I can plug my laptop into the internet while I drink my tea. But if you think this is the ultimate in computers being everywhere, this is Thad Starner, who doesn't just take his computer wherever he goes. He wears it wherever he goes. I want to ask you a couple of questions about privacy, okay? Okay. So pull up your privacy file. Okay. You got it up? Yep, pulling it up right now. It took that little time. Now you got all your thoughts about privacy.
Well, I have a couple of things on cryptography and some of the other things we worry about with this technology.
What about when the glasses get really normal looking, and I never know when I'm talking to somebody whether they need glasses or they're just trying to look into my soul? I mean, shouldn't I worry about that?
Well, basically, you have to trust the other person just as you would trusting them with a secret or trusting them with something you don't want to spread around. You don't want them to go off and tell everybody, in the world.
Yeah, but I might trust you, but your stuff may be going out over the internet right now, and there may be people you don't even know who are getting information about.
Okay, so what I'd like you to look at here is the fact that I'm typing with my left hand. I'm typing these notes, and the system is pulling up in real time files that might be relevant to what we're discussing. And going back here, and this was happening live at the time. This is post-processed because we couldn't put a camera where my display was back then. But this is the sort of thing that my display was giving me at the time Alan was asking me these questions, and so it really helps me seem more smart than I am. I've used this before when testifying to the National Academies of Science in the U.S. If you see me on a panel somewhere, you'll see me doing this as well. But the idea is that I have this second brain that's always looking out for me and trying to suggest things that are relevant. And in fact, what we started doing, one of my students, is using speech recognition, and this was about 2002 or so. We're using speech recognition that everything I say is transcribed and put into this this is an Emacs buffer. The text editor is called Emacs. Everything I say gets put into a file, and that's continuously being searched by the remembrance agent to suggest things that might be relevant to the conversation. Now, this is the first time we actually start thinking about AI through symbiosis. Now, what do I mean by AI through symbiosis? Now, artificial intelligence, as we've seen recently, really demands big data. You want more and more data in order to train up a machine learning algorithm in order to understand the world about you. But mostly, so far, what we've been focusing on is machine learning systems that can actually look at large amounts of images on the web, like pictures of cats versus dogs. I think that was the first one that Jeff Hinton showed in 2012. And by using this huge amount of data that's on the web, millions and millions of images, we can actually train up a system. And we're using these large supercomputers, distributed supercomputers, to train these systems up. The problem is there's only so many problems that we can address using data that's on the web. So we're creating machine learning algorithms that are very good at understanding the internet, very good at understanding the web, stuff that's out there. But it's very poor at understanding everyday human interactions. We're no closer, really, to having a computer that can reside in a human body and stand up and walk across the room and shake your hand. We have, our computers today have very little idea of what it is to interact face-to-face with humans. They have very little idea what it's like to embody a human body. So what we would like to do is create a wearable computer that sees as we see, hears as we hear, looks at how we say things, how we move our hands, how we interact with the world. And from that large amount of data, from gathering it from everyday life, it learns how to interact in the human world. And what does the human get back in return is something like this, a recommendation system or an intelligent agent that helps us in our day-to-day life. So what I'm going to do is show you an example of that as well. And again, my apologies here for a little bit of trouble with our switching back and forth. But we'll get this up in just a second here. There we go. We'll be conservative with how we do this. So this is an agent that basically listens in to your everyday speech and tries to provide some help with it. Now, in this case, we're looking at something very simple, which is countering. When somebody comes up and asks you, can we meet sometime next week? Generally, you have to get out your phone and get to the right spot and look it up, and it takes a while. As a matter of fact, most often people will say, well, just send me an email and we'll schedule something. Well, that seems really silly. Why can't we schedule something right when we meet? Why don't we have ability to actually work together immediately on our calendar? And one of the reasons for this is simply that humans are very impatient when face-to-face in conversation. Even small pauses in a conversation are intolerable. For example, in this day and age, even that small pause, you're assuming that something just happened to the audio signal. And if, I think we're having some difficulty with some feedback here. If people can mute, I'd appreciate it. So what we see is that people, in order to maintain the speed of conversation, folks are willing to immediately to delay decisions or delay calendaring until later. So what we're trying to do here is make a system that listens to your speech as you're interacting with somebody else and provides you computer support as you do it. So this is again an idea of symbiotic AI, something that's actually learning about the world around you while it's providing you some service. So let me show you how that looks.
Now we replay Bob's speech input through the Calendar Navigator agent, along with the resulting navigation he sees in the head-mounted display. When Bob is engaging the push-to-talk button, we will show this visual indicator. Though the Calendar Navigator agent uses only Bob's speech, the original conversation video is overlaid in real time to give you a feel for the interaction as a whole.
Hi, Alice.
Hey, Bob. Hey, can we meet next week?
Next week, you said?
Yes. How about Monday?
Monday? Yeah, let me check. I'm busy all day Monday. How about Tuesday?
Tuesday at 1 then?
Sounds good. I'll pencil you in at 1.
Great, thanks.
As our scenario shows, a dual-purpose speech interaction leverages the user side of a conversation to perform an additional function, such as mobile control of a computer. By using push-to-talk and a noise-canceling microphone, recognition accuracy is improved and third-party privacy is ensured. Together, these form an interaction technique that augments conversation in a socially appropriate way.
All right. So that was a system from 2004, but yet now we're seeing that sort of idea again with how people are using Google Glass. So I'm going to pull up a modern.
Right. Your PPT, it seems like it is gone again.
Yes, I'm pulling it up right now.
Okay.
I am because we're having trouble with the share. What I'm doing is doing these things separately, so that as I pull them up, if something fails, it won't be much of a problem. So here we go. This is going to be a video. So this is not by me. This is actually by a company called Augmetics, which uses a headboard display to help doctors do patient interviews. And we'll talk a little bit more about what's going on here in a second. But think about this interaction through the gaze, through the idea of an AI that's monitoring your conversation, trying to provide services while you're interacting with somebody else.
The most rewarding part of being a primary care physician is the relationship that we have with our patients.
It was love at first sight, I'll tell you. First we hugged. Very unprofessional, but I love it.
There was a time when I was not doing so well, and she called me home to check up on me. You'll get through this. It really touched me.
Glass, can you pull up the healthcare maintenance for Micah? I see that you're overdue for a couple blood tests, nothing that's class allows us to stay in the moment.
I tend to feel maybe a little nauseous. It clicked with me when she wasn't sitting at the computer all the time.
No sinus symptoms.
She was really able to look me in the eye. That made it a lot easier for us to interact.
Couple more deep breaths for me. It's a service called Augmetics. If we need information, it's brought to us. We don't need to go to the computer to get it. Class, could you pull up what I said about her thyroid nodule from last year? Yeah, so it's completely unchanged from last. It's hard for patients to remember everything that we told them to do. As things are being said, notes are being created live in real time. Here's your after-visit summary. Here were your vitals from today. In the past, almost a third of my day was spent with my computer. Now I spend maybe 1 to 2 minutes per patient.
Since she has the nimble glass, she is not as rushed. Honestly, not as rushed. My middle son is going to be Santa again.
Glass gives us a little bit more time to interact and get to know our patients.
Okay, let me take a look.
Yeah.
Oh, there you are. Oh.
That's what makes the job really fun.
Now, I would like to go back and look at some of this again. So how Augmetics is doing this is it's actually a human note taker on the other side of the connection. So Glass is sending the audio and video to a, I think it's just the audio, to a transcriber who's actually controlling the interface the doctor sees. Now, the reason this is happening this way is that in the US, there are laws about using automatic speech recognition for medical services. And I think we'll see those change over the while, but currently you're not allowed to actually use computer speech recognition, if I remember correctly, for medical records. So what's happening here is a human is actually typing in this information. And whenever the doctor says, can you show me the records from last year about Maya's thyroid, that human note taker is providing that information to the doctor on their head-worn display. But one can imagine that you could have an agent, an AI, who actually uses all this data that Augmetics is getting to make a system that automatically pulls up this information. So by having a human in the loop currently, sort of what we call a Wizard of Oz interface, where the human is pretending to be the AI, we can gather more and more data in which to create an automatic system. And so Augmetics here as a company, I believe, is getting a lot of wonderful data from a first-person viewpoint, from the human's viewpoint, of how to create an automatic human assistant for day-to-day life. And so this is one of the projects I think that really excites me about having these wearable computers in the real world. We're finally getting computers that can see as we see, hear as we hear, look at our actions, and learn from us on a day-to-day basis. And it's not like we're intentionally training them. We're just training them from living our normal lives. And that way is a way we can get big data, large amounts of data for training these machine learning systems without it being an onerous task. Okay, so we're going to go now back to my slides. All right. So in the past, we've done many versions of this. And since we did not, since we lost some time for the during the start here, I'm going to skip over some of the details about privacy, networking, heat, power. Basically, the challenges you normally have with making the devices. We can cover more of those challenges of how difficult it is to make these things work in real life in the second hour. But for now, I'd like just to show you another example of how we can actually create AIs that are symbiotic. This is a captioning system for the deaf or hard of hearing. So recently we've seen that speech recognition is getting a whole lot better. Whereas the system I made for the calendar navigation agent back in 2004 could barely handle a couple hundred word vocabulary. These days you can get live transcription. In fact, one of the great things if you have an Android phone is that you can actually get something called Live Transcribe, which I will show you here. So let's try this. So this is my cell phone. This is just a standard Pixel 3 XL, and I'm using the Live Transcribe app to transcribe what I'm saying in real time as I talk with you. And if you're interested in this sort of thing, you can either download the Live Transcribe app from the Play Store, or if you just push your volume down button or volume up button, you'll see at the bottom of your screen a little thing that looks like a square and a little screen. And that is the captioning system that everything that comes into your phone will be transcribed. So this is part of basically every modern Android phone out there. And it works pretty good. You can get versions of this where the transcription, scroll it up here so you can see it better, where the transcription is done either in the cloud, which gives you better results, or is done locally. The local stuff tends to be better, so you don't have to worry about network lags. But this now is just standard. This is, everybody has this, or potentially everybody has this. So given that ability, can we actually help people who are deaf or hard of hearing? So what we're going to show is a video here of Jim Foley. He's a professor at Georgia Tech. He does computer graphics, and he has been losing his hearing. And he's been helping me develop this work for the past 7 years or so. What we do whenever we want to test something is we have him pull out his hearing aids, and he tries this system, which is kind of fun. Let me pull up a video of that now.
Okay, Glass.
And again, it helps if I can share this. There we go.
Start captions.
Hey Jim, how's it going?
Great, Jay. How are you today?
Pretty good. I had a question about the classes you teach. I wanted to know if I could help you at all with the class.
Oh, what a great offer. In fact, I'd like to show off Google Glass and this application to class.
How long have you been teaching here at Tech?
Jay, I've been teaching here since 1991, about 22 years ago.
I gotta head out right now, but I'll see you in class.
All right, super duper. Thanks. Bye-bye.
So by having a system whereby we can caption everyday life, we now have the ability for our AIs to really understand person-to-person communication. This is helping people who are deaf or hard of hearing who may miss a word or two see in their eyepiece exactly what's going on, and they can pay attention to somebody's lips while looking at the screen. And so you can imagine, walking down the street with a friend, instead of holding the phone in front of you, you just walk and see the display. But meanwhile, the system again is hearing what you hear, seeing what you see potentially. In this case, it's just has the microphone on and it's getting data, and so it's providing a useful service. At the same time, it's actually understanding, getting much more a variety of speech that it can hear and train on. So that's pretty exciting, and that's something that you can play with right now. Here is a slightly different thing. This is helping people who are blind or low vision interact with objects around them. Now, the idea here, this is by Brandon White and Jeff Bingham, Andrew Miller. Jeff Bingham is now at Carnegie Mellon. And the idea here is they're using a headboard display and camera to tell people who are blind or low vision what it is they're looking at. So let me show you what that looks like.
Video, we test open glass with 2 visually impaired users. First, we show question answering, where a user asks a question and receives an answer from Mechanical Turk or Twitter, and the answer is read aloud.
Share with. Open glass. What is this box say on it?
Okay, glass. Share with. Open glass. What is this a can of?
Press.
Okay, glass. Share with. Open glass. Okay. What is this box?
So right forward and then little tap. That worked, right?
Next, we demonstrate Memento, where a sighted user associates objects and scenes with annotations. A visually impaired user is then read the annotations in real time. A native application streams images to the server where they are matched. Any matches are then sent back to the glass where the text is read back to the user. Memento. These are the power tools. See Sean Kane for information. These are two 3D printers. On your left is Andromeda, and on your right is Enterprise. This is the laser cutter. Be careful.
Right over here, by me. Right here. And you're going to stand right above here. So you want to turn around. Okay? And right over here where I am, you're going to look right towards this. See these tools? So look right at it. See shot information. Yeah, so it's recognized.
So it's reading what's in front of you right now?
This is C shot for information.
Exactly.
Now, what's kind of cool about this project is this was Brandon White's student project while he was a PhD student, I believe, at the University of Maryland. And again, what we're doing here is we're training up a system to recognize the world around you and provide messages for people who are blind or low vision to hear. But the Amazon Turk version of this, the version of it where the images are sent to humans who annotate stuff and then send the information back. Well, one can imagine using the many thousands of images that this project created, or I should say the VisWiz project created, to actually train up an object recognition system for the artificial intelligence. So here, by creating stuff that, again, that sees as we see, hears as we hear, actually assists people in their daily lives, we're actually, again, giving the AI real-world input of how it's like to live in the human world with human senses. And so I think one of the most exciting parts of this project when I first saw it was the fact that the VisWiz project, the system that this was based off of, really was practical. We saw folks using it to navigate a parking lot or figure out, what temperature their oven was. We had folks using these sorts of systems to determine if there are allergens like peanuts in the cans of food that they were shopping for. I think the most surprising one was when this project got a picture of a pregnancy test where somebody sent an image that said, "Am I pregnant?" And if you think about that, if you're blind, of course you can't see your own pregnancy test, and it's not something you're going to ask a neighbor to help you with. But this woman was okay with sending that image to anonymous people on the internet to tell her whether or not she was pregnant. And of course, now there's some data out there to help determine, to frame up a system to recognize a pregnancy test system. So all this is very exciting to me, and here again is that approach. We're basically using a wearable to combine with machine learning to discover the human world and how to interact in it. And in this series of talks that you're getting for this program, you're talking about how to do a smart city. How do you use artificial intelligence, machine learning to make a smart city? Well, in order to do that, we really have to have basically smart individual assistants. And what we can do is basically have this first-person perception of the world around us and share that to create these intelligences that understand how things work around us. We're going to do an example of this from some of my early work that gives you an idea of how simple these algorithms can be. And why this actually has a chance of working where previous efforts in AI and machine learning have had problems. This actually might have some legs to it. So this is an algorithm that my student Dan Ashbrook and I invented back in the early 2000s. And variants of this algorithm are now used by Google and other companies to distinguish where semantically meaningful places in the real world. So how this works? Well, what we did back in 2000 is we put GPS systems on a lot of our graduate students. And we just had continuous streams of GPS data as they went about their lives. And remember, back in 2000, selective availability was just turned off. GPSs were not very good yet. And so your resolution was had just changed from 100 meters to 10 meters, which is still not very good. But what we could do is we could just get a lot of data as people traveled in their daily lives. You get something that looks like GPS trails. This, excuse me, this is a part of Atlanta, the city in which I live. And Atlanta has a core, which is called Midtown. And then the main part of the city is within this circular called the perimeter. This is 285. That sort of defines what most people consider the heart of Atlanta. And it's quite wide, it's like 20 miles in diameter. What we're seeing here is that as my students are traveling the area, we're basically discovering the map of the region just from people moving. Now, the thing is that this, recovering the map is kind of fun. It's visually, intuitive. But what we really care about is getting to the stage where we get semantically meaningful places. For example, what work is, or home, or grocery store, or hardware store, that sort of thing. So what we do is take this stream of GPS data, and then we just determine where the GPS signal stops. Either where the person stays in the same place for 10 minutes or more, or when we lose the GPS signal for 10 minutes or more. Generally, when we lose the GPS signal, it means you went indoors, you went in a subway, that sort of thing. And so these we call places. And then we start clustering these places to determine locations. Now how does that work? Well, what we do is a variant of the sliding means algorithm. We take a circle of radius r, and the radius could be 100 miles to begin with. But here I think our radius is about 100 meters or so. And we start with a pick your place. We put a circle of that place, and we look at all the places within that circle. And then we calculate the mean of all those places, and we move our circle to that spot. And we keep on doing this algorithm, this iteration, until the system stops in one spot. And then we take all those points, we call those points, those places, we call those a location. And we are going to then take those points, those places out of the system, and we're going to do this again. And we'll start clustering again and again and again. And what happens is when you start with, say, a 100-mile radius, what you get is basically cities pretty quickly. And my group at that time was working between Zurich, Switzerland, and Atlanta. And so we quickly discovered that there were two main locations we're working in, Zurich and Atlanta. But we also then saw that if we took all the places within Zurich and Atlanta and clustered on those, we would then start getting campuses like the Georgia Tech campus, the CDC campus, the Emory University campus, or people's homes, that sort of thing. And so what we can do is we start with a large radius, and we shrink the radius, and we count how many places we get in per location. And what you discover is the knee in the curve, where you don't get the standard exponential that you expect here. If we can, just somebody can mute again, please. Thank you. Oops.
Who is now? I think you have to. Nelson Alkindi.
Okay. Nelson, can you please mute your audio, please?
Yeah. Nelson, can you just switch off your mic?
You need all this and this close to it. All right. Bios look into the macro level, micro level, wicked problems, and you need all this.
Let's see if we can.
The other part is talking about, okay, if you're talking about strategy, you really need a leader.
Yeah, I can mute her, but then
to make sure that you can execute it, lead it, all right? And if you are having a leader without a strategy,
let's see here.
Is still
let me make sure it's not coming from me. That'd be ironic.
Yeah. It's not coming from you. Hold on a second.
Leadership. Symbiosis.
Anybody can tell me how to.
You have heard of this term. You search Google. This is really a biological term. Biology.
Nelson.
Okay, can you hear me again?
Yeah, I can hear you now.
Okay. So what's great about this system is it can be fully automatic. Once you have this knee in the curve, you know that there's something humanly meaningful here. And what do I mean by that? It turns out humans tend to move and reside in very distinct places temporally or spatially. Our houses tend to be a certain size. Our businesses tend to be a certain size. Our campuses tend to be a certain size. Same with our cities. And so whenever you do these sublocations, whenever you do this sort of sliding means clustering, you always get these knee in the curves that are very distinct. And so it's easy, surprisingly easy, to discover different scales of meaningful locations. A city versus a campus versus a building versus an individual entrance at a door. So here's an example of this. So suppose we'd already discovered this location called Georgia Tech campus. Now we're going to look within it at other places, and we soon can do the same sort of subclustering where we discover individual buildings. And from that, we can actually get a unique ID of these individual buildings and start actually creating a Markov model that predicts when we're going to go one building another. Now, one great thing about this too is once you discover the location, you can often add semantically meaningful names to it. For example, where you are at 3 a.m., on average is generally home. Where you are at 2 p.m. is generally work. And you can just label these things automatically that way. Matter of fact, if you use Android, you might have seen that on Google Maps, it automatically suggests a spot for home and a spot for work. And it's using an algorithm like this for it. But the other thing you can do is start looking at basically yellow pages, a reverse lookup of a physical location to an address, to a name for that address, and start labeling things automatically from the information that's already on the web. And from that, we can now go from these named locations, and we can start predicting our behavior. For example, if I look at my behavior for a month and I discover that I go from home to work or home to school or home to video store, I can count the number of times I go from one place to another, and with simple math, just count the probabilities when I'm going from one place to another. And I can actually create a simple first-order Markov model that predicts, given where I am, in this case CRB was work for me, where I'm going to go next. And what we discover is that second-order predictions are actually much more powerful than first-order predictions. For example, I might go from home to work to the grocery store, but I almost never go from home to the grocery store to work. And so I can use that to predict things. And one of the things that's done with Google Glass is when our users would step out the door, of their building, the system would see the GPS signal and would then pull up a suggestion. What happens with Glass is the way it works is there's a little bone conducting transducer here that actually pings you whenever there is a notification, and it can then show you what suggestions it has. In this case, it sees you go outside, it pings you and says, oh, I think you're going to San Francisco next, or you're going to Fry's Electronics, or you're going to the hardware store. Here's the traffic along the way, and here's the route I suggest you take. And this was magical for our users in the sense that the system could provide you information without you asking for it. It basically was almost reading your mind about what you want to do next. Now, since I'm running out of time, let me finish up this idea with something that's much more difficult. So, we just used location and showed how we could cluster location and get some meaningful information from it. Can we do that from everyday human activity? So one of my students, again, this is pretty old work, put the equivalent of a modern IMU, accelerometer, gyro, magnetometer on his wrists. And he started doing exercise routines with dumbbells. And he did 32 sequences of exercise routines and then used a clustering algorithm to automatically discover meaningful routines. And how does this work? Well, basically all he's doing is looking for self-similarity of the accelerometer accelerometer and gyro. He's looking for self-similarity in that motion, and the system automatically discovers the 6 different exercises he was doing and labels them with like 97% accuracy from these 32 sequences. So now we have a situation where we can use an algorithm and automatically discovers human activities and labels them for us. So instead of these fitness sensors like with Fitbit that counts your steps, imagine I have a wristwatch that whenever I go to work out with weights, it discovers what exercise I'm doing automatically. I don't have to program it at all. It just discovers it and it counts my number of repetitions. Well, that gets a whole lot more interesting when we start looking at things like sign language. Can we use the same algorithm to discover the signs in sign language? And the answer is yes. It turns out that using some old sign language databases, we discovered over half the signs in the sign language. And this is actual real language here. It's discovering the fundamental units of that language. We can also discover how objects are used by how they're manipulated by looking at the hands and how they're interacting with the world, we can actually discover objects. In this case, we have a book. And you can't judge a book by its cover. If I was trying to do computer vision to recognize books, it'd be very hard because books have many different things on the covers: trees, humans, whatever, coins. And so if I use a computer vision recognizer, it'll just say whatever's on the cover. But if I actually use an activity recognizer, it sees you page through the books and can recognize the fact that this is an object by how it's manipulated. And so we can do this at a higher level. This is Alireza Fafi's work. He was a PhD student at Georgia Tech. He's actually looking at what the hands are doing and automatically discovering the objects that are in this environment, and then bagging them up into different activities. And so he can he can distinguish between, are you making a peanut butter sandwich or a cheese sandwich? Are you making coffee or making tea? By the objects in the environment and how you're manipulating them. And so this is where I get really excited. We're finally at the stage where we can actually have these systems live our lives with us and start understanding what it is to be human and provide us information on a second-by-second basis. You can imagine using Alireza's work to help people with cognitive impairments maintain jobs, go to work and have cognitive support. You do this step, then this step, then this step, as part of their daily lives. Okay, so I'm afraid that I'm out of time. The big idea again here is the idea of collecting first-person data from on-body sensors. We can do a lot of the processing locally right now, though a lot of the training is going to be done on these supercomputers. But this is finally a way that we can get the big data we need in order to actually understand the world around us from a machine learning perspective. Okay, thank you very much. I'll take some. We can take some questions. Rita, I don't know what our schedule's like now, but
the schedule. Hold on. The schedule of the video.
Well, certainly while Rita is looking at things, if there's any questions, feel free to put it in the chat or just unmute and ask. I'll mute my microphone so we don't get any feedback.
The schedule is that we have got hold on. The schedule that it is like 9 to 9:30 that we have got a recess and also time for networking. So it should be the time for networking and also recess now. And then so this is a preparation, and then the 9:30 that we will come back and for the second section. So yeah. So Fred, do you have any other suggestions? We have got a question that is like why I think the question should be addressed to you. The glass technology seems to be there for a long time, wondering why it is not be able to do as for research. So Fred, it seems that yours is like mute.
All right, sorry folks. So glass has been continuously sold since it's been sold every year since 2014. And we started glass as an experiment. And the reason why we stopped selling the glass XC was because we were running out. We only made a certain number of them for the experiment. And what we discovered is that it really took off with industry. And so Google decided to focus on industry as opposed to the consumer market, because there was really a lot of demand.
Sorry?
I'm sorry. Did you not hear any of that?
Yeah.
Okay. So I'll start again. So glass was sold from publicly from 2014, 2015, and has been sold every year since then. But the experiment that was glass, the original glass, was had a limited number of devices made on purpose. It was an experiment. And what happened is that there was a lot of enthusiasm with the explorers at first. And a lot of people wore it in their daily lives, but where it really had a lot of impact was in industry. So in industry, what we saw is that things like Augmetics, remote expert, order picking, these sorts of things, manufacturing, these industries really could use it, and so Google decided to focus on those industries. Now, we saw the same thing happen with the original PDAs. Before the Palm Pilot basically established the industry, there was the Zoomer and the Telzon systems. And so we saw early on with PDAs, personal digital assistants, that it was adopted by industry early on, and then it took a while for the technology to get small enough and slick enough for it to really take off. And one of the things I think that needs to happen with head-worn displays is they need to basically disappear into eyeglasses. They need to start looking like everyday glasses. And what we'll do in the second part here, we'll start looking at those types of glasses. So this is something from North Focals, something from North called Focals. And it is a head-worn display, which basically looks like a normal pair of glasses. Now, you're seeing something in my glasses right now. That's my screen reflecting in these glasses. But I'm going to turn this on, so we'll have it for the next section. And what we're seeing is more and more companies making head-worn displays that disappear into this sort of form factor. I'll show you a couple variants coming up here. And so what we need to do is get rid of that disruption. Like whenever you wear something, it's fashion, and it doesn't matter what the functionality of the system is. If it's not fashionable, if people don't want to wear it in the first place, they won't. And so I really believe that these devices need to start looking more like this before we'll really see a takeoff in the consumer market. Okay. And so feel free to, like I said, I'll have many different examples of these head-worn displays coming up in the next hour, and that's going to be much more informal, and we just talk about all the gadgets I have. All right. Any other questions, or did I answer your question sufficiently?
Para, so directly to be integrated. In fact, do you need to have a break, or you answer the question for me?
Okay, I see it. So the question is, would you ever consider this technology to be directly integrate biologically? You already do see some of that. We currently have pacemakers that are quite intelligent. They actually adapt to your exercise rate, your body output. We have deep brain stimulators that help people deal with depression or deal with Parkinson's. We have a lot of implantable technology out there already that's actually getting pretty smart. The question is, are we going to see it for more consumer items? And the problem is infection. As soon as you break the skin barrier and try to do anything permanent, you get a difficulty with infection. Now, there's one exception with that. For people with type 1 diabetes, there are continuous glucose monitors which there's a little, if you look at Dexcom, is the name of the company, they have a little device that you put in your belly fat. And it's just filling with some little needles, and you put it right on your belly. And it's got a little bandage that goes over it. And you wear it for days at a time, and it streams your glucose level to your wristwatch or your smartphone. And so you can adjust your eating habits or your insulin based on that. So we're seeing, and a lot of people are now hacking their own hardware. Dexcom has sort of encouraged folks who want to do this to look at their own data and use it to improve their own health. And so we're seeing folks trying to make AIs or machine learning systems that can predict what types of food are going to be good for them, or if they exercise a certain amount, will they need a candy bar later? And so we're actually seeing folks starting to do this sort of thing. Now, if you're talking about things like, am I going to do direct brain implants for augmented memory? That's going to be a ways yet. First of all, memory is spread throughout the brain. It's very hard to locate any particular point to interact with. Elon Musk is talking about this with Neuralink. But the thing is that it's unclear that direction is going to work. Can you actually interface with a particular point and discover the cell in your brain that recognizes your grandmother? Or is it going to be more distributed? And the problem with any of these direct brain implants is the risk is huge. And so you generally only do these direct brain interfaces whenever you have no other choice. All the direct brain interfaces you're seeing in the news is people who are having seizures, and they have to actually have these interfaces to help maintain, to help eliminate the seizures they're having. Otherwise, they wouldn't have the surgery in the first place. But while they're having those electrodes in there, people are starting to use it for interfaces as well. So if you look at the Stanford work or any of these brain-computer interfaces work that are invasive, it's mostly with people who have basically no other choice than to have these electrodes in. So it's going to be a while before we see people doing this as non-medically necessary.
Okay, thank you. So maybe Fred, you can have a short break.
Thank you. I'll take it. I'll get myself some something to drink, and let me. I'm going to start up all these devices so that we can talk about them in just a few minutes.
Yeah.
I'll be right back.
Sure. Oh, for the rest of the yeah, right, Nelson, what you say is correct. Just fill that, and then there is a web box that come out saying that you have submitted it successfully. The red box is actually what it said is that you have submitted successfully for the evaluation form. So for the rest of the folks, we need your help to fill the evaluation form so that try to give Fred high marks in any case. Yeah. And then if there is any sort of like collaboration for us, okay, thank you. But for us, we actually we have got a fintech program in our university. So if you know anybody who would like to study for like undergraduate for fintech, then you can just let me know. And then we have got a number of the collaboration that is in like AI and ubiquitous studies. We have got something that is like call for paper. So if you have got friends or whatsoever that he or she may have got something that would like to submit, just let us know, because we have got quite a number of the call for paper now that includes like AI ubiquitous study for this series of talks. We have also got construction safety, that is we have got safety science call for papers, where there's about the AI and also the safety stuff in safety science, and also some other thing else. So feel free to feel free to let me know if you have got any ideas, etc. And then while we are waiting for like Fred to come back, you can also like introduce yourself to everyone, like see what kind of research that you're doing, and then what sort of like collaboration that you would like to achieve, etc. Directed to the okay, sure. I'll send you the link of the evaluation form. Unmute Taverna. Oh, okay. Unmute. Yeah.
Okay.
Yeah.
There we go. So this allows me to see myself large. Oops. I'm going to try to set up this camera. It's a very bright display, so it's hard to actually do this well. Can you not hear me, Rita?
Yes. Yes.
Yeah, I think I'm going to unmute. I'm going to mute this one. Sorry, don't do anything. I'm going to change my.
And now, can you still hear me?
Yes, sure.
Okay. So we are going to have two cameras running from the Tavener account and from my Starner account so that folks can see what I'm seeing. At least we're going to try to do that. So just tell me when you're ready, Rita, and I will try to make these things happen. Rita, do you know if there's a way to actually be able to show multiple people on the screen at the same time, like a grid view? Oh, you know what? That's why I need to do it this way. Okay, I'm going to unmute the Tavener account so that I can get the focus of attention there, if that's okay. Oh, looks like you have to do it, Rita. Can you unmute Tavener again? My apologies.
Sorry, you mean to unmute you? I think yours is, you mean ask to unmute Tavanda, right?
Yes, please.
Yeah, it should be like unmute now.
Thank you. I'm going to try saying a couple things here, make sure I can still be heard. And let's see how much magic I can do here. There we go. Okay, excellent. So just tell me when you want to restart, Rita, and I will.
You can just start at any time that you like to. When you're ready, you can just start it now, maybe.
Okay.
Yeah.
So folks, this is going to be much more informal. I have two cameras running. You can see the good quality camera, which is the one that has the better color. But I also have a fisheye view camera that I'm going to be using to show you my different screens as we work. So to give you some sense, we have many different types of head-worn displays here. And I have a lot of their boxes behind me. And we're going to talk a little bit about the different points of making a head-worn display-based wearable computer. Now, the first thing to know about these systems is that fashion matters. Probably the most important thing. So you really have to make something that people desire to wear, no matter what the functionality is. If you, as soon as you put something on your head, it is fashion, and people are surprisingly, well, I guess unsurprisingly, focused on how they present themselves. This is why people wear Rolex watches, or why people dress the way they do. And so never underestimate the importance of fashion when making a piece of wearable computing technology. But then one of the next things you have to worry about is comfort. And so one of the problems we're seeing right now is that a lot of people who work in making head-worn displays are focusing on the wrong thing. They focus on things like resolution or field of view or 3D recovery of the world in front of them. What that ends up with is very heavy systems. I'll give you an example of what I mean by that. Let me pull out here, and hopefully I can do this without causing problems. This is a toy system that you can get from Lenovo, which is actually pretty fun. It's part of the Star Wars work. So, yeah, nice return Jedi challenge stuff, and this was sold for a while out there. And it's one of these systems where you put your phone into the system, and it acts as a display, and then you put this thing on your head. Now the problem is that this stuff weighs way too much. So once you put this on the head with the phone, you have this huge lever arm, and this thing just hurts to wear for more than about 20 minutes. And one of the things that, let me put down the lightsaber. This is a fun one. We're going to actually look at how much this stuff weighs. So this is a standard scale, food scale. And we can see that with here, that's 520 grams without even the phone. So you add the phone to it. Let me see if I can find my phone. I just had it here. There you go. So add the phone to that. And now that's almost a kilogram on your head. So this is not something that is comfortable for any amount of time. And so we see the same mistake being made by Microsoft or Magic Leap. Well, Magic Leap actually is a pretty well balanced system, truthfully. Meta had the same sort of issue. And they'll promise these great systems, but they're just too uncomfortable to use. I'll give you another example of this. So folks oftentimes think that these head-worn displays are a relatively new phenomenon, but we've seen these ever since late 80s, early 90s. And one of the main players has always been Sony. Sony, for a while, was selling these systems.
System is that, right?
So this is the Sony HMZ T1.
Okay.
And the idea behind this system was that people who are, people who have a new apartment in Japan, you just graduate college, you have your first job at some company, and now you have an apartment, but your apartment is too small to have much room for a big screen TV. And so Sony's idea here was that you could have a large screen TV if you wore it, right? And so I remember what I said about fashion, right? Now, the idea is that you're going to be at home alone while you're using this, so the fashion in theory doesn't matter, but you still got to make something people want to wear. And the problem with this thing really is that not that the technology isn't great. There's wonderful displays in here. This is 2011 that they made this thing,
Yep.
The technology in here is magnificent. It is really good stuff. A high quality screen, good good binocular system. You can actually.
It is a kind of like the thing that is similar to the idea is like try to put a television in this small little system.
Yep. And what's kind of cool is they also have one of the big problems with headboard displays is what's called the interpupillary distance. And so, people's eyes are different sizes. And so what they've done is create little levers here that you can slide the displays and increase or decrease the size between them.
Yep.
And another thing they're trying to do with this system was make it so that it would hold against your head. But the problem is that there's incredible amount of nose weight here. This thing, when you just put it on your head like this, let me show you how much nose weight there is. We're going to do the same. Pull up my scale here again. I actually haven't done this, but we will in the past. But we will assume let's see if I can do this well. Oh, no, that's not going to work. We're going to assume that I'm wearing my head, so what I'm doing is holding it where it'd be on the back of my head, and I'm measuring the nose weight. And so now I'm actually seeing 380, almost 400 grams of weight on my nose with this system. And so when I have curiosity, I just couldn't imagine how the Sony salesmen were selling this thing. So I went to the Sony store in Palo Alto, I believe, or maybe it was here in Atlanta, and asked the salesman, to try it on. I kind of already knew a lot about the system, and I said to him, well, this is kind of uncomfortable. How are people supposed to wear this thing? And he says, well, what you're supposed to do is you're supposed to lie back on your chair so that the chair behind you takes the weight. And it was just amazing to me that was the response. Okay, so what happened is what we saw is that the specs on this is a 720p display. So what's that? 960 by 720, something like that. Like I said, really good optics. And so the optics and the specs for the system did not change, except for the head weight. So this is the 2013 HMZ3. And the idea, again, was you're replacing this for cinema. And now you can see that the system has a little strap here that's supposed to tighten down, take more of that head weight off. And the only thing that's changed, I've got myself stuck. The only thing that's
looks like HoloLens, that type of stuff.
And the only thing that's changed really is the head weight. Oops, I didn't tear the system first. All right. So now we're actually, instead of 400 grams, more like 300 grams. And so what Sony basically did for the industry is they basically showed that if you're making a head-worn display like this, where you have a strap that goes over your top of your head, you basically want your system to be around 300 grams. And that starts being comfortable. Interestingly enough, Sony advertised this as the wireless version of the HMZ T3. This is the wireless version of the system. And you say, well, but there's a wire here, right? Yeah. Well, interestingly enough, you can actually send video to this system over Wi-Fi or through infrared, but you have to power it using a cable. And so what I think happened is that Sony was trying to make something that was all self-contained, like the HoloLens, include the battery and everything else. But they realized that if they got to, if they did that, the head weight would be too much from their experience, and people wouldn't be comfortable with it. And so, their wireless system, they gave up on the wireless idea just because they realized the battery would add too much weight. At least that's my interpretation of what happened. Now, along comes Microsoft the HoloLens. Sorry, I can't see. I need to find my glasses. There we go. So along comes the HoloLens, and with the idea that you want it all be self-contained. And what we had is, I think the HoloLens is like 600 grams, even more than that, 700 grams, something like that. And so the HoloLens the HoloLens 1, at least, was a great demonstration for about 20 minutes. But nobody wears it for like 2 hours. It's just it's literally too painful to wear. So Microsoft did not learn the lesson of Sony before them about what the weight limit was for these devices.
Yep.
Now, HoloLens 2 is better. I do not have one in my collection. I do have a HoloLens 1. But we see the same mistake over and over again. The Meta display had the same sort of issue. This Lenovo has the same sort of issue. The early VR systems had this issue. Now, interestingly enough, there is a Chinese company called DVPR. Whoops, I'm going to drop these things all over the place here. DPVR, excuse me. And they're selling a cinema system with the same sort of head strap. But they have found the magic formula to make a system that is actually only 280 grams. And so they focused on making it lightweight and inexpensive. And I believe they were selling like 5,000 of these things a week. It was pretty good at the time. And this was several years ago. They found the magic formula for inexpensive and lightweight. But the problem is that to be a success in this space, if you're talking about $1,000 units, you really have to sell like 2 million to be considered a commercial success. If you're selling like $300 units, you gotta be more like 4 million. And we really have not seen anybody do that except for the Sony PlayStation. The Sony PlayStation VR system, I think they're at 4 million or 5 million at this point. And even then, Sony does not really consider that a success yet. I don't know if it's because they're losing money on the hardware, what's going on there. But there is a real idea that people buy the VR headsets and just put them on the shelf. And we've seen that before back in when these stereoscopes, in the 1850s, there were these headsets that you could get with 2 pictures on a card. And you could actually see the scene in 3D. It was basically 3D photography. And if you were a middle class or better family, you almost always had one of these things in a cabinet somewhere. It was a fun little entertainment. But that's all it was, a fun little entertainment. It wasn't something you brought out every day. Matter of fact, it might be only something you bring out once or twice a year. And so that's a lot of where we're stuck with the VR headsets. It's something that people buy as a novelty, especially the PlayStation VR stuff. But we're not seeing, that the everyday use you want. Folks recently have been getting the Oculus Quest and Oculus Quest 2, because and has all the specs that people claim they want. But it would, and so the Oculus Quest has gone out there. But if you look at the reviews, you have reviewers just saying, "Hey, look, I thought that this was going to be the best thing. It has all the specs I want, but I use it for 20 minutes to play Beat Saber, and it gets hot and sweaty and uncomfortable. And I don't use it for 20 minutes." So people are realizing that these systems are just too uncomfortable to wear.
Yeah. So do you think that, Fred, just one question interruption. Do you think that actually the future of the research, it should be like improve the weight, just like the one that you are wearing? And then can like show all the things for which the computer can display, and then it will not hurt the eyes, because if everything is like too close, then say for instance VR in Hong Kong, a lot of circumstances, the teachers actually reflect us that they were worried, the parents were worried that the display stuff in the VR is too close to the eye and leading to like short-sightedness, because in Hong Kong a lot of students that they are short-sightedness, and then if they play with VR, there would be like another problem like short-sightedness by the time that they have run it to a long time. So would that be a future of the research that if, like for example, that it can display everything without like short-sightedness that they
Well, actually, it's not the VR that you have to worry about. It's the cell phones. So the problem that we're seeing with children is that they're all getting cell phones early on, and they're all reading them like this.
Yeah.
Right. And that encourages the eye to focus much more close. And with a VR headset or any of these headsets, the focus is actually at a distance. Using some of these VR headsets, in my opinion and in my experience, having the optics there so the focus is at a distance significantly improves your eye health.
Significantly improve the eye health?
Yeah, compared to actually having a phone where you're holding it, close to your face. People hold their phones about 14 inches. What's that? About 28, 35 centimeters from their eyes. And your eyes are not designed for that. Your eyes are designed to focus at 2 meters. So if you design your headset to be at 2 meters, which is what glass is, glass is actually designed to be focused at 2 meters. And so are some of my other systems that I've made in the past.
Yeah.
And we do that. You can use these systems all day and have a better experience than using a laptop or a cell phone. Okay. Just because almost all, if you see a professional programmer, oftentimes they have a lot of big screens around them, but then you realize that they're sitting back from the big screens. It's not like they want a big field of view. It's not like they're up to their screens like this.
Yep.
They're actually sitting back. So people who program for a living, you oftentimes see them sitting back from their screens because they've sort of intuited that this feels better.
So the one that you're wearing also have got the object detection that it can like try to tell whatever thing that is like in front of you, right?
Yeah. So a lot of folks are trying to make these sensors, and the talk I just gave is about AI through symbiosis and having computers see as you see, hear as you hear. But it doesn't matter if people don't wear them.
Yeah.
So this emphasis on cameras and depth sensors, I think, is misplaced. Because let's think about for a second, what's the most successful display out there, and it's the cell phone. These things, and these things were very successful. These devices were very successful without all the sensors being with. Now, once you add a camera to it, it got even better. But I think there's a lot of room to have a small field of view, thin client, low cost device that does minimal things like just text in the market. And we're seeing that with smartwatches too. Smartwatches are now a successful wearable computing industry, and they don't do much. All they do is a few lines of text or some numbers, your heart rate, a SMS, a calendar event. They don't do very much, and that's all you really need. It's just some relatively simple interactions on this one displays, and you're gonna have a better system. Let me talk a little bit more about fashion. So, I said fashion was a big idea, a big issue, and I don't have no pair of glasses. I'll use more focals here. We'll pretend these are normal glasses. And so there's a couple of things you can do. Either you can make a pair of glasses like this, where the system disappears, or you can make something that gets out of the way. This is a system called Scalar, which I love because it's a good gadget. And see if
What kind of thing is that? Sorry, Starner?
Scalar.
Yep. Scanner.
And it's a display that actually goes on your glasses and pops in and out. It's motorized. This is very science fiction.
So what is this kind of thing? It looks very interesting, but then what kind of thing is that?
This is made quite a few years ago in Japan. The model is called a Teleglass 3. I don't know if you can see that. But and it just hooked into your.
Can you type it? Oh, I cannot see the screen very clearly. The words on it. What kind of thing is that?
Let's see if I can do it here instead. Teleglass 3. And this one is, I don't have a source for this, but I really don't know what they marketed this for, so it's kind of a cool mechanism. Let me show you some other devices here. What we'll do. Let's show. So I have these systems running right now. Let's give some sense of what is currently available. So I have a couple systems here. Let's go with this one. So this is the Vuzix system, and if I get on the right angle here, I'm not see it. You can actually see the screen. So let's hook this up to. I'm gonna put this in front of the.
Okay, so this one is for what? I can see something inside. It looks like a HoloLens. I mean, that there are something inside, but what kind of thing that is it that it can display?
Well, this is a full Android system, so it can display anything you want. It can do video clips, take pictures, that sort of thing. Do an SMS email. In fact, let's see if I can. Nope, that's not looking very well. So we can find some more videos here, but what we can do, hopefully, I can show this to you. There we go.
There are actually something inside on and off, but it's more or less same as before. I see it.
But why I can do it? Sorry, I need to.
I'm not sure what kind of thing is that. So it's more or less similar to the previous one. It's like it has got some color thing inside.
Give me 1 second here. I have to, in order for me to see what I'm doing, it keeps on changing the video on me. So what I'm going to do, so I have a chance of seeing what you're seeing. There we go. So this thing has a trackpad on the back.
Yep.
And as I scroll through, there we go. Hopefully you can see me scrolling through the menus here.
Not yet see the menu. I think they have got something, but then this is like.
So this is a full up computer.
Okay.
And Android is Linux. So if you wanted to, you could have a Bluetooth keyboard on this and type your email. One of the things you would use this for in practice is an industry for remote expert. There's a little camera here, and somebody at a distance might be instructing you on how to fix a car or fix a problem with a generator and a power plant.
Yep.
So the idea is that you could carry these glasses around with you, put them on whenever you need to get some help as a repairman, and somebody remotely can help you with that. Or another thing you could do with this is order picking. So $1 trillion worth of goods are picked from 1 million warehouses every year. And most of those are done by hand because robots don't have the manipulation abilities of humans. So the problem is that when you're given a sheet of paper with what to pick, you tend to make a lot of mistakes. These things are called pick lists. So what people have been doing with these head-worn displays is providing graphical representation of where to go in the warehouse, how to get there, where to look on the shelf, and what to pick. And by doing this, you can actually increase accuracy by about a factor of 10 to 1. And you can increase, you can decrease time by about 40%. But there's some problems with this particular type of display. Right? One thing is that, let's see if I can do this again. Is that I said the limit for these helmet style systems is about 300 grams. Well, the limit for head weight on one of these eyeglass systems is around 75 grams total, but only 30 grams on the nose. Let's see how well the Vuzix Blade does. Well, here's the total weight.
Yep.
So we're at 96 grams. And now let's assume that I'm wearing it on my ears. See how much the nose weight is. The nose weight is 63 grams.
So it is quite heavy.
Yep. This is about twice as much weight on the nose that it should be.
Yeah.
In order to actually be able to wear it for an 8-hour shift. And so while we're finally getting to the stage where, this is starting to look like an old pair of glasses.
Yeah.
But there's two problems. Number one, it's too heavy for comfort. The other thing is that if I'm trying to use this in face-to-face conversation, besides the fact that it looks kind of funky, you can imagine somebody wearing something like this and it not being too remarkable. But as soon as you get the right angle, I'm trying to do it here. As soon as you get the right angle, you can actually see the display as a bystander, and that light is really I'm really having trouble doing it for you here, but hopefully you got a flash of it there. So when folks are trying to use these systems in everyday life, they don't want to call attention to themselves. Because people treat you differently if they think you're augmented.
There's one question from the audience that is like, why is the device heavy on the nose part? So it's very strange, right? Actually, it can be like part of it can be like spread over to like the ears. But then what you say is that it is heavy on the nose part.
They're doing the right thing here. They're trying to put some of the batteries back here to counterbalance it. And that's a good design.
Oh, okay. I see.
You can see that glass. Oops. Where's my glass? There we go. Glass does the same thing. It puts the batteries in the back.
Okay.
But the difference here is that by getting this wide, this larger field of view, this is thick glass here. This is, I think, about 7 millimeters of thickness.
Yep.
And so, it's not actually glass, it's some polycarbonate, I suspect. But that amount of, you're putting a lot of glass right over the nose. And it's coupled, in order to do this, they have a little diffraction based display here. The actual display is in this piece here, and so is the driver board for it because it's all got to be one thing. And that's why this thing, folds back here. And so all the computation, all the light engine, everything is up here. And that's why it's so heavy.
Okay.
So
it means that actually when there is like the next breakthrough, it should be like the weight should be like the material side, it should be a lot much more light in weight so that it can be really put into practice. Actually, because it's like it should be very useful, right? Because actually the computer can be like wear on the face.
It's a compromise, right? So it's a compromise between field of view, resolution, battery life, all these things. This particular architecture is not very efficient.
Yeah.
In other words, I think, for every 10 photons you put into a display, you get 1 photon out or something like that. It's only like a 10% efficient display. And so this is why with this display, they turn it off very aggressively. So they want you to use it for small interactions and get back to the display clear, because otherwise the battery doesn't last. If you have the display on continuously, it lasts for about 2 hours. And that's the problem. Now, one nice thing about that one though is it has a big eye box, and we're gonna talk about this for a second. This is the North Focals. Now these look much more like normal glasses. As a matter of fact, and I love it for that. That's probably the best thing about these glasses is they look like normal glasses. It's great. Now the problem is though something called iBox. And the other display, you saw that I could pull it up to my camera and show it to you pretty easily. Well, with this one, we're gonna have a bigger problem. So I'm gonna try to do this here, and we'll see if I can. This is me having a lot of experience doing this.
Well, this one is just like the ordinary glass. We cannot see anything on it.
Hold on for a second. So if
okay.
I can, actually, Rita, can you mute yourself for a second so I get so I can see myself? There we go. Up, maybe.
Oh, something come up. Something come up now.
But Rita, if you can, okay, there I can see it. There we go.
Yeah, something that it looks like computer stuff now.
So this is a laser display.
Yeah.
It's actually laser scanners.
Yep.
But you can see that as soon as I move a little bit, I can no longer see it.
So what is the use of it?
So this is for SMS, turn-by-turn directions, seeing your email summary, fitness. You play little games on this, you get maps on it, that sort of thing.
So another question that I have is like, so this one is like used when, say for instance, you are on the street, and then you stop there. For example, you just stop and sit somewhere, so that you have nothing to do. That you can just use your glass to like check emails, obtain the information. So
you're walking on the street, you can use it to figure out where your next turn is.
Where is the next turn?
Yeah.
So it's like finding the ways to some of the destination.
Yeah. Think about the head-up displays in cars that are used for navigation, or head-up displays in cars that are used to show your speed. Well, you can do that same sort of thing now as you walk from one spot to another. For me, as I spend a lot of my time in California and Atlanta, my students notice send me SMSs if they want my attention. So one of the things I do is if I'm walking and a student sends me an SMS, I can pull it up right away, see what they send me and respond right away. One of the other things I have is a keyboard, something called a twiddler, which I have over here. Give me 1 second. I'll show you what that looks like. Okay, this is a fully functioning keyboard that allows me to sustain about 70 words per minute. And for me, I can, with some of my other wearables here, I can basically have the equivalent of my laptop in my glasses, not these glasses, but some of my other glasses. I basically don't need my laptop. I have everything on my glasses.
Yeah.
And for, I guess from, I don't know, about 1993 until 2010, when I started making glass, my primary machine was my wearable computer. So that means if you saw a paper from me or got an email from me, it was written using this keyboard, or actually the predecessor to this keyboard, and a head-up display. I didn't have a laptop. I didn't have a smartphone. What I had was a wearable computer. So my PhD dissertation, which was about 250 pages, was written on a display. Let me see if I can find it here. Yes, it was written on this display. And well, this is my original wearable computer. This is like 1994. But my PhD dissertation was written on a display like this. And my connection was that Zoom modem I had there with a over a analog cell phone. And the more recent version, so from about 2003 to 2010, I had a display that looked like this. This is a micro-optical SV6. And so this would fit on your glasses, like so. And this is a 640 by 480 full color display. And it would go down to a computer. It's called a Charmit. This is one I think I had a company called Charm. This was basically like the Apple One. It was a hobbyist system we sold that you could, basically get a fully assembled system, but you were expected to tear it apart and fix and maintain it yourself. So this was, I think, the a 586 at 200 megahertz at first, but became a 800 megahertz system eventually. And so again, this is what I did my work on. Now, so you can with a system like this, get rid of your laptop, get rid of your desktop, have a full up computer.
So you're working also on the wearable jeans, right? So what is the use of it?
Wearable what?
Wearable jeans.
Oh, the jeans jacket, that sort of stuff. So one of the big things with wearable computers is the interface. I've spent many hours learning how to type on this system, so that I can actually type 100 words per minute with one hand. But not very few people will spend that time to learn these systems. Can we make interfaces that you can use while on the go? You can use while riding your bike. You can use while driving your car. You can use while walking on the street. Can we actually make interfaces you can use in your daily life? And so there was a lot of work on trying to integrate interfaces in clothes, like a jeans jacket. And so we actually implemented this keyboard interface on the chest of a jacket. So you can sit here and type very effectively. You sit here and type very effectively, just using the buttons on this jacket.
Okay, that's crazy enough.
Yeah, but it worked. It's not something I did in daily life. It was research.
So how heavy is those like wearable stuff that you just mentioned?
The jacket?
Yeah.
The jacket's just about the same weight as a normal jacket.
Oh, I
There's
see.
not much to it, especially.
So it's just for your like typing on the jacket.
Yeah, but also if you're getting an incoming cell phone message, you might have a dual cell something like this called the Levi's Jacquard jacket. If you're riding your bike and you get an incoming voice call, you just send it to voicemail. Or if you want to take the call, you can double tap and take the call. And so the idea is to make interfaces that take very little attention. And this is the key thing to wearable computers, whether it's a smartwatch, a head-worn display, anything. The key advantage you have to a wearable computer is that it reduces the time from your first intention to do an action and your first ability to respond to that action. In other words, for me to answer my cell phone, for example, I have to get the phone out of my pocket, get it up, unlock it, and then answer. With something like the glasses I have on, I can just do this, and I'm done. I'm answering, and I'm talking to myself. Or with glass, if I have an incoming cell phone message, I can just nod my head up, and I'm into the call. In fact, while I have this here, I have this working, we can actually show you what glass looks like. Hopefully. So
this one is the one that you wear all the time, right?
Yes, this is the one I want to wear all the time.
Yeah.
And so what's nice about this is it's much easier to see the screen.
Yeah, I can see the screen, but then I cannot see exactly what the words are there or the figure that is shown there.
This camera's focus is too far out.
Yeah.
I'll back it out and see it. Also, the screen is too bright.
Yeah.
So it's very hard, surprisingly hard, to actually share your screen this way.
Yeah. So what kind? Maybe you just let us know what kind of things that is displayed on the glass.
Well, for me, most of the time it is the time, right? So, and that is surprisingly useful, right? Especially when I'm teaching, I always know, how many minutes I have left in the lecture.
Yeah.
But also it's things again like SMS. Liking a message when I'm teaching. Also, if I have my glass on while I'm teaching, what I can do is often have my notes of what I'm going to say next up in my glass. I can also control my lecture slides using the glass device if I like. So
these actually also utilize the AI technologies, right? Because or just wearable computing.
Sorry, say that again.
Does it also involve like AI, or it just involve like wearable computing stuff?
Most of your daily life stuff is just the interface. Having quick access to a display. Is the advantage.
Yeah.
And people are seeing that a lot with smart watches now, right? Having the ability to see an email, see an SMS, see turn-by-turn directions, see calendar events, see the time, see the weather, sporting scores, all that sort of stuff, fitness data, all that stuff you see on the watch is actually better on a head-up display. It's faster, it's easier. You can do it while you're in motion. It's supposed to try to keep running and looking at this. But where I see this going is eventually we'll get these displays back to a point where you have a full computer monitor in something that looks like this. And you'll be able to sit here and type, right, either on a normal keyboard on this and replace your laptop. So everything you're doing with your laptop right now, you'll be able to do on here. That's what my old systems were, and that's what we're going towards. Now, the thing that I do a lot of, or I did on my older system you saw, is take notes on conversations. You saw that in that Scientific American Frontiers video. As I'm talking with the actor, with Alan Alda, as he's saying things that I found interesting, I was typing down the notes. Well, I do that with any scientist I'm with. If I have a Nobel Prize winner sitting across from me at lunch, and he says something interesting, I'll type in notes real quick to remind me of that conversation. And then I have access to those notes 20 years later. So as you saw with the Remembrance Agent, it looks to see what I'm currently saying and pulls up things that are relevant to the conversation. And to this day, when somebody starts talking about electronic noses, the ability of computers to smell things, a conversation will come up that I had with the founder of Cyrano, one of these electronic nose companies, over lunch, where he basically explained to me how electronic noses work. And so within seconds, when my student asked me about electronic noses, within seconds, it seems like I'm an expert on it again, because I have one of the founders of this company's thoughts right on my eyeball. In more extreme times, whenever I'm like testifying or having a panel session, a lot of times what I'll do is have my students tune into what I'm saying. I'll actually show them what I'm seeing, and I'll give them access to my screen. And so my students can give me answers to questions I'm getting. I was at the National Academy of Sciences a few years ago, and they were asking about human augmentation. And what I showed them is both my slides as well as what I was looking at, which was a screen that had all my students on a teleconference. And the students were listening to what the questions were being asked, and they'd throw me links and throw me what to say. And the panel, the people who were asking questions, soon realized that the real smarts in the room was not me, it was my students. And so they started just asking my students questions through me to see how they would respond. Again, this is where these displays can make you seem a whole lot more intelligent than you are, either through the computer augmenting your intelligence, or through getting a superhuman level intelligence by being networked with other people. And when we talk about superhuman intelligence, we talk about three ways of it's going to happen. One is we're going to create an artificial intelligence that's smarter than we are. The second way is we're going to augment people in their everyday life so that they're smarter than a normal person. Or we're going to network people together in ways.
How to network people together?
I'll give you that was the example I was just saying. Having other people listening to your conversation so they can provide ideas. But there's another way to do it too. So let's see if I can go back to the Remembrance Agent here. I will share my screen again. Yeah. So I said that this is a system that as you type or as you speak, it suggests things from your past that's relevant to the conversation. Well, when I was part of a student team working on this project, one of the things we did was actually share our databases. So when you have a wearable computer, when you have a device where you can type in notes all the time, you tend to do it a lot. And so there were three of us who actually shared our notes on a daily basis. And oftentimes, my Remembrance Agent would actually suggest other people's memories would be relevant to the current conversation. And one time I saw this being used by a friend of mine, Brad Rhodes. This is when we were up at the MIT Media Lab. And I've been asked by, I think, Hewlett Packard, HP, about self-powering cell phones. Can we actually make cell phones, smartphones that generate their own power? And the next week, I believe it was Microsoft was asking Brad the same question. And Brad said to them, I don't know the answer to that, but I'm typing some notes here. Let's see if Thad does. And my notes on what I had said the week before, Hewlett Packard came up to on the screen. He started actually saying the same words that I had used before. Now, Brad did not realize I was in the environment. I was getting ready to get up and introduce myself and take the question. But I found it astonishing that Brad used my memories of this conversation the week before to answer the conversation that I was having now. So basically, we're feeding all our memories together, even though they were just text memories, feeding all our memories together so that all of us could actually benefit. And this sort of intellectual collective, sort of social networking on the most intimate scale is another way to increase intelligence, at least in my opinion. Let's see.
So Flat, if like for example for like research, what kind of thing that you think that it will be like the research direction that will be for like wearable stuff or anything that you think that may be the next step in academia?
I think one of the biggest things is going to be this augmented memory work. This idea about supporting people with these devices in real time on a split-second by split-second basis. Having context-aware devices that really can augment memory. Let me give you an example. So when you have eyeglasses like this,
yeah,
you don't think about them. Right? They are correcting my vision so that I can see the world around me. And they basically become part of me. Right? There are. I don't think I put them on in the morning. I don't take them off until the evening. And everybody who sees me thinks of the glasses as part of me. And so I see through the glasses. They're just part of what I am. But can I do the same thing intellectually? Can I actually make intellectual augmentation such that I think through the AI? Can I make an artificial intelligence that augments my intellect, augments my intelligence, such that I think through the system without realizing it? Meaning today, we already have some examples of this in a very loose sense. Nobody gets lost anymore because they have a GPS on their cell phone. It used to be that if you were going somewhere, that you had to download, you had to get maps, like paper maps, or if you had a computer system, you had to download them ahead of time. But now GPS and these phones are with you all the time, so you don't think about navigation problems. You just use it. This is how Uber and Lyft work. It's just part of the job. Can we make systems where when I have conversations with you, I'm being continuously augmented by the computer? Can I make a system that when I say, can we meet next week, it automatically pulls up my calendar and suggests me times? Can I make a system which is kind of like a good English butler who's always beside me and always knows what I need before I can think to articulate it? Can I have the equivalent of what billionaires have, their assistants who are always with them and helping them? Can I have that sort of assistance, not just for billionaires, but for everybody? I think that's where this stuff is going to go. It's going to be very powerful.
So it's a ubiquitous computing, like happen everywhere.
Well, yeah, wearable computers is a practical way to do ubiquitous computing. One problem with trying to put infrastructure in your city is that you have a problem with maintenance. Who's going to maintain those systems? Who's going to fund those systems? Who's going to replace the batteries? Who's going to, if you put wireless repeaters in every telephone pole, when it gets run over, when there's an accident, who's going to replace that? So by augmenting the human as opposed to augmenting the environment, we have by definition an easier way to do ubiquitous computing, because all we really care about is augmenting all the places where humans are. Now, I'll change a little bit. I'm starting to augment and dolphins and other things. But in general, wearable computing is the cheaper, more sustainable, more shorter way to get ubiquitous computing out there. I mean, already smartphones, if you think about the deployment of smartphones, we have billions and billions of them. We're getting lots of data from the smartphones. It's one of the most successful ubiquitous computing deployments ever. I think we have more smartphones than more phones, at least, more cellular phones, digital cellular phones than we have people.
How about the application of AI for ubiquity? Like, what do you think that is like current state of art for the application of AI for ubiquity?
Well, so one of the things I showed you was the using the GPS to recover positions of, to recover the map of the city, recover important locations, but you can also recover traffic patterns. We're always seeing that. Google Maps will show you where the traffic patterns are and reroute you. We do other things as well. We can look at the level of noise in the environment. We can look at, so we can look for noise pollution. We can look at foot traffic patterns. If we add, other sensors to these devices, we can look at things like, radiation or air quality. So having these mobile platforms to get this data and start recovering it in daily life allows you to really understand what's going on in your city in a very good way. Right now, what we're seeing in the U.S. because of our out of control break of COVID, a lot of people are using an application called Novid, which tracks people's location, uses ultrasound to figure out if you're in the same room, and can tell you whether or not you've been exposed to somebody who's been recently diagnosed. Well, it's taken a pandemic for us to share this sort of data, but one can imagine that with that data, if people chose to share it, we can find out a lot about human patterns, human movement, human interaction, communication, how people work with each other. We can probably optimize that. We can improve people need to talk to each other. So we can actually use the AI, we use all this data to train up an AI to help help humans be more effective, be more independent, be less stressed, this sort of thing.
Okay. So there's a lot of innovative research. We benefit a lot. So any questions from the floor that you would like to ask?
While we're doing that,
This is also another one that you have made, right?
This is not this one from Epson Vario. It's not something I've made. It is a commercial product.
Commercial product, so it's available in the market?
Yeah, this is an Epson Vario BT300. And it's a wired system. It's a full Android device. It comes with a little thing that's about the size of a cell phone.
Yeah. So what is the major function of it?
Well, it's again a full Android device. I don't really know what they're selling it for. It can play movies. It can do the remote expert thing. It can do the order picking thing. So it can be a full up computer. You can use this instead of a laptop if you want. The problem is it's in my opinion it does everything only sort of well. It is a nice compromise on all the use cases. It can act like your smartwatch. It can act like your laptop. It can act like your phone. It can act like this notification. Do the same sort of stuff the glass does. The only problem is that if you look at it here, it is, it looks funny, right? You can see that my eyes look silver. The nose weight is, I said nose weight has to be less than 30. And our nose weight here is 68. The entire device weight is 78. So the entire device weight's okay. But it's too much weight in your nose. And so, while it's wonderful technology, and if you're interested in augmented reality or wearable computing, I highly recommend buying one of these things. It's nice technology. But it's not something you're going to use on a daily basis. And one of the biggest things is when you turn it off, the screen is not see-through.
Yep.
You get these gray rectangles.
Okay.
So it's very irritating to have these gray rectangles in front of you if you have to clean up and coming up and down all the time. So you really have to take it off and put it in your pocket. But it doesn't fold right. You can't. It's kind of hard to have it like this. I guess you can put it in your pocket like this. It's not too bad.
How much weight is this one? You put it on your pocket.
This one is 78 grams for the headset, and for the phone part, it's 160 or so.
If it's a weight is a problem. Main challenges.
Yeah. So the first thing we got to take care of is comfort and weight.
Yeah.
My apologies. I think I just killed my other camera. So now I only have the wide angle one with the funny color. We can play with some of these other ones. Let me see if there's any other things that are particularly useful here. Let's see, this is the previous version. So before the BT300 was this one.
Looks also very heavy, I think.
Yes. This one's nose weight is 160 grams on the nose. The entire system is, for the head mount is 260.
Just a bit curious. The one that you always wear, how much weight is that? The one that you showed me last night, for example, how?
So what I'm wearing currently out of my daily life.
Yeah.
The whole thing weighs 54 grams. That includes all my lenses, like my actual prescription lenses.
Okay.
And
this one is also in the market or not?
Yeah, this is a Google Glass. This is and the nose weight is 27.20
grams.
The current one that's on the market is this is Google. This is a brand new Glass Enterprise Edition 2. So this is the third version of Glass. You put it on glasses. So you can clip it on the glasses frame, and it folds up.
Yeah.
Full wide. So this is the one you can buy right now. You can
go
to CD or some of the retailers to buy it. So its weight, its full weight is 48 grams, and I don't have the frames right now, but we can pretend. And the nose weight with this is like 8 grams. The reason for that is that back part here, that's really well balanced.
Yeah.
And so most of the weight is actually back on the ear, not on the nose.
Okay. So this one is only only sold in like the United States, right? Because it seems that I cannot see it in Hong Kong at least. I have seen the smart glasses, but not the Google Glass, I think.
Yeah, I do not remember what all markets glasses. There is a knockoff coming from China that was called Chipsip, I believe. that had a lot of features on it, and I was trying to get one for my collection. So I do not know how good it is. My friend Mark Billinghurst, I think, has one. He says it's not bad. So if you're interested in getting something like this, look for chipset. But the other thing that's good to look for if you want to try a wearable computer is a Vuzix M100. It is a pretty lightweight system. Get ones that are integrating glasses. Those are bad. And what you gotta watch out for anything that has too big a boom coming out, because it bounces around too much when you walk. So you really need to find glasses that the ones that just clip on your normal glasses. They tend to fall off. They tend to shake around too much. So you really want something that is firmly attached to the glasses and don't move when you walk.
Yeah.
And I'm trying to see if I have one of those right now, but it doesn't look like I have one here. Nope, sorry. Yeah, so if you're interested in playing with some wearables, I would highly suggest the M100. Of course, Glass Enterprise Edition 2. If you're in China, the chipset. There's another one another one's not bad is the ORA1 from Optimat. That's a decent system as well. And if you're interested in augmented reality stuff, and having the stereo vision, all that sort of stuff, it's not really practical for everyday use. If you're doing research, the BT300 is hard to beat. It's inexpensive, gorgeous displays, two-eyed, nice technology.
Yep. Great.
You just don't expect to wear it every day.
Yeah. So thank you very much.
Certainly.
Yeah, it is very interesting. And then well, if your Google Glass is on market in Hong Kong, do let us know, because I think that quite a lot of us should be very, very interested in this kind of stuff, like including what you said about wearable jacket and wearable jeans. Well, I think it is not yet available in Hong Kong. It is available in the United States.
Well, there's variants of these things all over the place. You can if you go to Akihabara, you'll find all sorts of wearable things enclosed. You can find snow jackets with controls in the sleeves.
Yeah, this is very interesting to us because I don't think that this is in the market. I think most likely it is in the research lab.
Now those are in the market. You can actually find those. Burton, I think, sells some.
Because a lot of circumstances that we are not sure, like for example, whether or not that there are some kind of repairments by the time that it is like out of order. For scientific research, yes, the researcher can repair it, but then a lot of circumstances that these stuff that we may have got a question, like for example how long they can be used, and by the time that it is like out of order, then we don't know how to repair it unless there's the one who invented it.
Well, this is why you buy several of them. I have I have a museum exhibit here. This is about 20 of the displays from my 100 display museum exhibit.
Whoa!
I have to really keep them working. I mean, some of these things. This is this system here.
In Georgia Tech?
It's at Georgia Tech. I sent it to Germany occasionally. It's been in China before at Tianjin. It's been in Berlin. But this is a system from, I think, 1997.
Yeah.
And this is a video viewer. This is the idea here was that you were going to use these to watch videos during plane flights from New York to San Francisco. But back then there was no in-seat entertainment. There was no in-seat screens. And so the idea is you'd hook this up to like a DVD player, like a portable DVD player, watching movies. And then when the video iPods came out, the idea that was that this was going to save these systems, and that everybody was going to buy these video iPods to drive these displays. The only problem was that it didn't work that way. It turns out people don't really care about image quality for movies as long as it's above 320 by 240 by 15 frames a second.
Yeah.
What they care more about is convenience and weight and portability. So people would not wear these. What they just do is take this,
yeah,
and watch their movie like this on the plane.
Yep. Right.
So ironically, what was supposed to be one of the best sellers for these sorts of devices,
yeah,
the thing that was going to save it, turned out to be a thing that really kind of killed it. Yeah. So I mean, there's just too much wires, too much inconvenience.
Yeah. So thank you very much for tonight's talk.
Sure.
Yeah, it's a bit overrun now.
Oh yes.
Sorry to bother you for such a long time, but then I think that all the thing that you have tried to make is like very, very interesting.
Thank you very much.
Yeah, just let us know if there is like anything that is in market elsewhere in Hong Kong or elsewhere that we may be your supporter for your products. So
Very
thank you.
cool. Remember, I'm mostly a professor at Georgia Tech. I just consult for Google. I spent some time doing work on glass, but most of the stuff here is other people's commercial products, Epson, Sony, that sort of thing. And
yeah,
the research, of course, is mine.
Yeah, the wearable computing should be the next step.
I hope so. We'll see there.
Yeah.
I'm certainly working on it for a while.
Yeah.
All right.
Thank
you very much,
Okay,
folks.
thank you very much. Thank you very much. So thank you very much, all of you. Goodbye. Thank you. Bye bye. So I'll just fill the evaluation form before you leave. So of course it's a very high rating. Thank you. Thank you very much. So see you. Bye bye. So this is the end of the talk. Thank you.